So what is meant by a controlled variable? Surely you can answer that by now as a Year 12 chemist. So they're variables that are kept the same for each experiment test so that the experiment can be valid. So for each test material, we keep certain variables the same, and that is a controlled variable. Okay? Identify factors considered when selecting a material for use in a marine environment. So based on what we've done, what are some factors that we use to select materials for use in a marine environment? Ability to prevent organisms like barnacles growing on it, that's a good one. We want to keep it not as dense as possible, and we want it to be strong. We want it to be corrosion resistant as well. Several other properties that we could have picked there. Explain why corrosion occurs more rapidly in a marine environment. So, because galvanic cells are set up. Metals in a marine environment readily form electrochemical cells with the seawater as the electrolyte. The oxygen is dissolved in the seawater, and thus water and oxygen are in close contact with the metal. The metal in ships are subjected to mechanical stresses, and stress points can easily become electrode sites. Okay? So numerous cells can form on the surface of a piece of metal, and the metal at the anode sites will corrode rapidly. Okay? So that's why corrosion occurs very rapidly, because we've got salt, which makes it a strong electrolyte, which means we can set up a galvanic cell. There's oxygen in the seawater, which means there's oxygen and water available. The metals in ships and other marine applications are subjected to lots of mechanical stress, and those stress sites can become electrode sites. And numerous cells can be formed on a single piece of metal, which can corrode very rapidly. Okay? Now in this investigation, let's list 3 controlled variables. Okay? Number 1, hopefully the size and shape of the metal to be tested. Okay? So we want the size and shape to be the same for each test case, and hopefully you can achieve that. Okay? The concentration of the electrolyte in each test, that's pretty easy to control. We can do that quite easily. And also the amount of electrolyte used. We want to make sure the amount of electrolyte is the same for each test. Okay? Otherwise it's not very valid. That'd be like, so for this one in particular, it'd be like saying, you know, here's a chunk of steel, put in water, and then here's a tiny piece of magnesium and put it in the water. You can see that that wouldn't be a very valid test. Okay? Why does each metal need to be only partially submerged? So I made a point of this as I went through this lesson, that the metal has to only be partially submerged. So now we're going to figure out why is that. Okay? So oxygen is a key element in the corrosion process, right? We know this from our previous studies. Now since oxygen is only partially soluble in water, the concentration of oxygen in a liquid source is far lower than in air. So the concentration of oxygen in water is less than in air. If the metal was fully submerged, then essentially the oxygen is constrained because only X amount of oxygen can be in the water at any one time, which could limit the rate of corrosion. Now, since this investigation is already a lengthy one, it would be beneficial if corrosion could be accelerated as much as possible. Okay? So this may be the only time where we want to corrode something a lot. So that's why we keep it partially submerged, to allow oxygen to constantly be in contact with the metal. Okay?